Okay, this video is a review over the reactions that we've covered in class in preparation for your quiz. So what I want to do is show you a few reactions, and we'll go through the different types and then also cover how to balance them. All right, let's take a look first at number 8. Number 8 would be an example of incomplete combustion. The reason why it's combustion is because oxygen is going to be a reactant. It's incomplete because you cannot form CO2 and H2O without carbon and hydrogen in the reactant side. So this one is just going to be written out. Aluminum, the metal, reacts with O2. Remember that O2 is diatomic. It will always be written as O2 when you talk about oxygen gas. And then aluminum oxide. Now my advice to you for these compounds is to go ahead and write the metal and the non-metal that are making the compound and their charges. Aluminum is in group 3A, so it's 3 plus. Oxygen is in group 7A, so it's a 2 minus charge. Remember that overall compounds equal a 0 charge, and so basically we have the crisscross going down, which balances out our positive and negative charges. So this 2 will come down with Al, Al2, and this O will get the 3. At this point, we have to balance atoms as per the law of conservation of mass. So 1 aluminum and 2 aluminums, 2 oxygens and 3 oxygens. So you can do an atom inventory where you have Al and O on each side, and you want to count atoms. So there is 1 Al on the left, there are 2 O's on the left, there are 2 ALs on the right, and there are 3 O's on the right. So what I would do here is I want these to be balanced, and so I would want to make this a 2. So I'm going to come and I put a 2 in front of Al. I still have the oxygens that are not balanced. I have 2 over here and 3 over here. The number that 2 and 3 have in common, the lowest common multiple, is a 6. So I know I'm going to need to put a 2 here, because 3 times 2, we always multiply the coefficient times the subscript, is a 6. So I would need to put a 3 here. 3 times 2 is 6. Now when I do that, that also changes my value for Al, so I need to go back and make sure I check that again. Now this side is 4, so I'll go ahead and put on this side a 4. So my equation would be 4 ALs plus 3 O2 makes 2 Al2O3. This is also a synthesis reaction because 2 things are coming together to make one bigger compound. We also call this a combination reaction. So on the quiz, you just need to know how to write the reactions and balance them. You do not have to know the type yet. All right, let's take a look at an example of a decomposition reaction. I want to take a look at number 5. 5 is decomp because you'll see this arrow here. This arrow means that water, that's a single compound, breaks down into its individual elements. That's what a decomposition reaction is. So this would be decomp. So the first thing I'm going to do is write down my water, and it says it breaks down into hydrogen and oxygen gas. Remember that hydrogen and oxygen are part of the 7 that ends up being the diatomic molecules that we have to put a 2 next to them. So this is 2 H's, and I have 2 H's. I have 1 O and 2 O's. So to make this balance, I'm going to put a 2 in front of the H2O. That gives me now 4 H's and 2 O's. I have 2 H's and 2 O's, so I'll put a 2 right there. So this is decomposition, and my coefficients read 2, 2, 2, and then if there's not 1, it's an understood 1. Okay? All right, let's take a look at number 4. It's also an example of a decomposition reaction. For this one, it's going to be a little bit more difficult because of my O's. So I'm going to show you how to do this one. Potassium chlorate. So notice that you got to go back and study those polyatomic ions. Potassium chlorate is KClO3. It breaks down when it's heated 2 potassium chloride and oxygen gas. Okay, 1K, 1K, 1Cl, 1Cl, 3 O's, 2 O's. So I need to make this 6. That's the number they have in common. I'll put a 2 here and a 3 here. Now that has made me 2 K's and 2 Cl's. So I can put a 2 here, 2 K's and 2 Cl's. Again, decomposition because a bigger compound is breaking up into smaller parts. All right, let's take a look at a double replacement reaction. We're going to go ahead and take a look at number 7. Number 7 is a double replacement, and it's also called double displacement sometimes because I've got compounds, potassium iodide and lead 2 nitrate. And notice what's happening. The potassium and the lead, those cations, are switching places. The potassium was with the iodide, now the potassium is with the nitrate. The lead was with the nitrate, now lead is with the iodide. So what I like to do is I like to put up on top the different players involved. That's potassium ion, and that's the iodide ion. Lead 2, because lead's transition, and nitrate. Remember on the polyatomics, let's keep the charge on the outside. And then they're going to make lead 2 iodide and potassium nitrate. So again, let's go ahead and write our reaction. I have potassium iodide, Ki, plus lead 2 nitrate. This 1 is going to come down to lead. This 2 is going to go out to nitrate. PbNO3 2. And then all I'm going to do is just switch places. Now I want the lead with the iodide. So that 2 is going to go down with the I, and the 1 goes with Pb. So that would be PbI2, and the K is going to go with the NO3 now. So K is 1 plus, NO3 is 1 minus. Since it's 1 to 1, I'm just going to simply smush them together like that. Now it's time to balance. 1K, 1K, 1 Pb, 1 Pb, 1 I, 2 I's. Now one thing you can do is keep your NO3s together like this. You don't have to separate it into N's and O's. What I like to do is say, okay, I have 2 NO3, 2 nitrates here. So I'm going to put a 2 in front of the KNO3 to make 2 nitrates there. Since I have 2 K's here, I'm going to put a 2 in front of my K on the reactant side. So now I have 2 K's, 2 I's, 2 K's, 2 I's, 1 Pb, 1 Pb, 2 NO3s, and 2 NO3s. So my coefficients are 2, 1, 1, and 2. And this is again a double replacement reaction there. So I'm going to block that off so you guys can see it a little bit better. All right, let's take a look at a single replacement reaction. This is where you have a single element that gets kicked to the curb. The best one to take a look at here could be number 14. Number 14 does have an acid in it. You're not going to have to know the acids, but they look like a compound just the same, so we'll go ahead and do it. So I've got aluminum plus sulfuric acid. This is a single element, and then it kicks out hydrogen on the product side, which is a single element. So this is single replacement. So I'm going to go ahead and write it out. Here's aluminum. Sulfuric acid, all acids have an H+, and if it's sulfuric, it feels icky because it ate too much. This is my sulfate ion, SO4 2-. So my 2 is going to go with the H, H2. My 1+ goes with the SO4, SO4. Then I'm going to produce, now aluminum is going to get with the sulfate. So remember, aluminum is 3+, sulfate is 2-. So my aluminum should get a 2, Al2. My sulfate, SO4, is going to get a 3. And then what's kicked to the curb is hydrogen. Don't forget it's diatomic. So again, balancing 2 Als, 2 Als, 2 H's, 2 H's, 3 SO4s, 1 SO4. Go back and make this a 3. So 2 Als, 2 Als, 6 H's, let's put a 3 here, 6 H's, and then 3 SO4s, 3 SO4s. So again, that's a single replacement reaction where a single element takes the place in a compound and kicks the other element out. All right, that's about it for writing chemical reactions. We've covered the synthesis or combination reaction. We've covered single replacement, double replacement, and decomp. The only other thing that we could do is we could take a look at, let me see if I can find a example of a combustion. I'll just go ahead and give you a combustion one as an example. So here would be an example of a combustion. Let's go ahead and do CH4, which is methane, and it combusts. So that's going to be plus O2. You need to know that combustion is going to produce CO2 and water, not in that order, they could be in any order. So then you do again, 1 carbon, 1 carbon, 4 hydrogen, put a 2 here, 4 hydrogen. 2 oxygens on this side, 2 times 2, 4 oxygens, so 2 plus 2 is 4, so I'll put a 2 here. So let's check that again, 1C, 1C, 4 H's, 4 H's, 4 O's, 2 plus 2 is 4, and that would be complete combustion because it is producing CO2 and water, and it has O2 as a reactant. So that is the video over balancing equations.